latest version of Bitcoin Core. As you can see, just came out 2 weeks ago. So I was going through the tutorial on how to set it up, and most of the documentation that I found were a bit hard to follow. So I had to create this tutorial for you guys and for myself for the future setups. So first things first. So I think the disparity between the versions come in with the drop of BuckleyDB. So now the legacy addresses are being phased out. The legacy wallets, I mean, are being phased out. Yeah, because of the adoption of SQLite. So with it came descriptors, which are a bit hard to set up for the first time, that is. So now we'll just begin by cloning the project. So I'm using Ubuntu. So this is UNIX based. So let me just go to the project and clone it. So I hope you have Git installed. So I'll just clone it. Okay, so the destination path already exists, so I can just say Bitcoin 2 and remove this last part. Okay, so because I had already cloned it, I think I'll just go straight. Here is the project. It's called Bitcoin, so I'll just open it in Codium. I'm using VS Codium, so I'll just open it here. As you can see, so it is just a new project, just cloned. So there's nothing new. So now this is the main branch. So we want to move to the latest version, which I think is 29. Not I think, I'm sure it's 29.0. So just to confirm, we can just list the tags. We can just list the tags and maybe sort them by their version. Not a Git repository, so I need to go into Bitcoin and do the same thing. And as you can see, the latest one is version 29.0, so I'll just check out to that. But first of all, so that I'll just do cd Bitcoin and then open in the same folder. Yeah, I think this is better. So now I'll just repeat the same command. I'll just do git checkout because you have already confirmed. So I'll check out version 29.0. Okay, so now we can see the head is now at here. So first things first, we'll first, because we are using Unix based, we'll just build with the Unix commands. So before building everything, we'll just install all the dependencies and then see how it goes. So these are the build requirements from line 45. So I've already installed them in my system. So I think for you guys who haven't installed them, you can do the same. And now because of the adoption of SQLite, we'll need this dependency, that is lib SQLite 3 dev. Okay, so I already installed it. So right now I'll just install the dependencies from this depends folder, as you can see. So I'll go into the depends folder and then make this project. I'll just make the dependencies. As you can see, there's a makefile. So I'll use all the processes. So that it can be just a bit faster. So I'll make and then I'll run the jobs in parallel, so that I'll use all the 8 processes so that it can be a bit faster. And because it will be taking quite some time, so maybe I can just pause and then I'll be back when it is done. We are done with the dependencies. Now we can proceed to the build part, because we are finished with the bottom part. Now we are going to the building part. So there are 3 commands that we should be running. The cmake build just creates the folders, the folder build and the files, and then this literally builds them, and then this one installs them. So this last command is the one that will enable us to be able to run the executable. Yeah, so we'll move from the folder and then run this first command. So it will do everything, set it up. After that, you'll see a build folder that will be included over here, containing all the files that we are supposed to be building for installation process. So we are creating the files, we are literally building them, and then we are installing them. So it will take quite a while. Okay, so we are done building it. Now when we refresh, you can see the build folder with everything that is required to build the project. So next we'll be doing this command so that we can build them literally. Okay, so it will take quite a while, so I will pause over here and return. I added this part based on the number of processors so that the build process can be faster. So I won't run this command, but if you want to have a global Bitcoin daemon and Bitcoin CLI, you must run it. It's just that I already have it, so now I will just install it. I will just run it locally on this folder, not globally, because I already have another node instance running globally. So let me just clear the console. So I'll get into the build folder, and then there's the binary one. As you can see here, these are the executables that we will be running. For instance, I can just run Bitcoin CLI, and you can see it gives us some options that we should use. Yeah, so I will just take a configuration file that I already created. This is a configuration file that I already created, bitcoin.conf. Yeah, this is the configuration file that I created. So I'm running it on testnet. I'm currently running it on testnet, yeah, because so I'll just create a new file and call it bitcoin.configuration file. So you can call it anything you like, so long as you correctly refer to it. So as you can see, so testnet pruning is 1000 gigabyte. You can put lower, you can put higher. So what I'll just change over here is this data directory. Yeah, I'll just change this data directory because I want to save it over here. So I'll just go. Let me just open a new tab for this case. I'll just go back and enter into testnet data, and then I'll print working directory and take the whole absolute path. The whole relative path. So now that's it. That is the relative path that I'll be using. So after I've run the daemon, it should create the necessary files and folders for initial block download, the IBD process. So right now I want to run the Bitcoin daemon with this configuration, this specific configuration. So now I'll just come and run Bitcoin daemon, and I'll put a conf flag to be equal to this one. Except bitcoin.conf. So now this is it. These are just simple configurations. So because we are using a prune node, we won't use transaction index, but for your case you can use a full node, so without pruning. But for me, because of space, so now I'll just run it, and when I run it, it should perform the initial block download. Yeah, so it can take hours to days because it must verify from the Genesis block, download them as it prunes them. So let me just enter. So it has started the process. So it is looking for the DNS seed and all the process that that we have learned so far. Yeah, so this is now it. So for me, I will not run it again. What I'll do, I'll just lift all the data directory from the last one, from the last node that I did. So I'll just cancel it. Let me just cancel it. And then what I'll now do, I will just take the data directory from my other. So I will just copy, it's in the projects, Bitcoin testnet 3, so I want to copy that testnet 3 to this folder. It should be recursive, so I think it will take quite a while because there's over here, as you can see. So what I'll now do, I'll just delete my wallets. Yeah, because we'll start from scratch. I'll just delete my wallets, move them to trash, and now we have an empty wallet. Nothing is there. So that is it. So now because now assume that I've done the initial block download, so now I just want to download the blocks that maybe have been mined after the process. So I will just run the same Bitcoin daemon. Yeah, so I'll just run the same. So as you can see, now we are step ahead. So now we are Now we are ahead. You can see the blocks that are now being downloaded are from 2025. That is today's blocks. So now we are going to the addresses. Yeah, so let me just go through the tutorial once again. So now this is chapter 1. We have already, so this is just talking about the required skills, which are just basic skills, programming, command line, yeah. So next, for me, I didn't create a Bitcoin core VPS. What I did was I used other means and then compiled from source. So this is what we did. This is what we did. This is what we did. Yeah, this is what we did. So now we are going to understanding the verifying your Bitcoin setup. Okay, we have run the daemon. Okay, so you can verify the block by getting the block count. This you can do. Okay, this is just a basic process. So I'll go back to the build and then bin, and then I'll do the CLI. Because it's not global, so this is it. You can see for the case of testnet, I think the target is a bit higher, so the difficulty is lower, meaning that the blocks are being generated so fast. With the mainnet, it is at, I think, 800,000, but here the testnet is 4 million blocks and above. So now we are verifying. So option on your server. Okay, so we are using testnet for our case. Yeah, we are using testnet. So we are going next. So this is just verifying, but as we can see, it is already working. Okay, so these are the directories in data view. So you can get the information, info. So this is the information currently. How many headers? So it seems we are at par. Verification process is at 100%. This is the difficulty, the version, the offset, and everything is there. As you can see, we are getting the same. So now we are getting to setting wallets. So now here is where we are going to the descriptors, as we discussed initially. So the legacy wallets are no longer available. There are no default wallets. As you can see, this tutorial is purporting, there are no default wallets. That is why I even deleted the wallet folder so that we can start from scratch, as you can see. So with the descriptors, what we do, we create a wallet, and then now what we can do is import descriptors. Descriptors are important because they assist in separating This can be mainly in cases where we are using cold wallets. They can separate the spending addresses from the receiving addresses. So, for instance, if you have a server, a workshop server, or maybe a POS system, they can generate the receiving addresses while you are using your cold wallet to generate the spending addresses. That is the private key. So the private keys and the public keys are in different places. So even when someone hacks the system, there cannot be loss of funds. So I think we'll now move to the wallet and wallet descriptors. Instructions again. So currently the wallet directory is empty, as we saw. We deleted everything inside the wallet, but for your case it came empty. And then now we'll be creating our first wallet. So I'll just use the same Bitcoin CLI, my local Bitcoin CLI, only this time the descriptors will be true. And we'll disable private keys. We'll disable private keys. So just as I tried to explain is that you can use this in secure systems. So let's say you have a POS that you only want to issue addresses to receive the payment, but you don't have to spend from that POS because it will be secure enough, because only the public keys will be there. It's a watch only wallet, so you can only watch transactions without spending them. So this is the first wallet that we'll be creating. Our wallet name will be maybe watch only. I will just take watch only wallet just to name it. Descriptors true, disable private keys true, and now I'll press enter. As you can see, now we have these two. So it has been created and loaded automatically. So if it wasn't loaded automatically, you could have just used load wallet. Here it is. You could have just used load wallet, and then you could have put the wallet name, that is this one. So for our case, it is already loaded, so you must load it in order to start using it. So as you can see, wallet watch only wallet is already loaded. So it's already loaded on our system. So now we'll go to the next step. And the next step should be to create an address. And because this we are dealing with the descriptors and such, so this one will not work, because in the past systems we were using the private keys were being stored specifically, like explicitly in the wallet, but in our case it is not stored. So because we are using descriptors, we will need to import the specific descriptors that we want to use in our wallet. So there are different kinds of descriptors. You can follow videos on YouTube to understand more. Yeah, but now we'll just try and load descriptors so that we can determine the kind of addresses that will be required. So most of the time we use the extended public keys, XPub. If you know what they mean, they are just extended public keys, like master public keys, which you can use to derive other many public keys that you can give to clients, or they can be generated on the fly. That is addresses. Let me just, so for this case, because most of the time, maybe because of security, you'll be having a hardware wallet that you will be using to perform this. But for our case, for simplicity purposes, we'll just use Electrum. So we'll just use the XPub that is offered by Electrum. So I already have Electrum, but maybe I can just take you guys through the installation tab to generate the descriptors for our descriptor wallet. So we'll go to the secure site. Kindly ensure that it is secure. Site electrum.org, but still will verify everything. So first thing, we will download this app image, the signature, and the public key. Import the public key and then verify everything. So I already have these commands. So what I'll just do, I'll just come over here. So this command just downloads everything. So I'm just using the AND command to link the three commands into one. Yeah. So the first one downloads the app image, the other one downloads the signature to the app image, and then the other one downloads the public keys that we'll be importing, so that we can verify that the file that we've downloaded, the app image file, is secure enough for us to use. So it's an important process, even if you're using testnet, but just to know, so you can just perform the process. So now the files are downloading. After they've downloaded, so what we'll just do, we'll import. So here we're importing all the public keys, as you can see, and then I'm still linking it and then verifying the file. So as you can see, it's a good signature. So if you receive something that is otherwise, you can ensure that you've downloaded it from the right place. So right now, I'll just make the app image executable. I'll just make it executable. Yeah. Now when we click yes, so now this is the app image, so it is now executable. But I also want to install it. So right now, when I look into my system, there's no Electrum icon. So I just want to create an Electrum .desktop for it and configure it so that I can be able to launch it from the menu. So I'll just create this file, electrum.desktop. Yeah. And then I will just add some few configurations. I think I have these configurations over here. I'll just explain what they mean. So this is just the version, the name, you can call it anything. This one, and then this is where we want to execute it from. So the app image, so currently I don't want it in the downloads. I want it in the temps, the temp folder. So I'll just move it. I'll just move Electrum to the temp TMP. Yeah, so now it is in the TMP. When I go to TMP, and you'll see the Electrum app image, that is where I want it. So it is the only thing I will edit. So print working directory. So I think it's shorter, we can type it. So it's in TMP. And then I think everything else is okay. Yeah. And this is the most important flag, because when you don't put this flag, it will launch in mainnet, but we are on testnet network. Yeah, because we want to use test coins. And then the icon, let me just see the, do we have it in the downloads? I'll just go back. Electrum logo, so we don't currently have it. Okay, so I'll just download the Electrum logo. Let me see if I can open the image. So let me just open this image in a new tab, save image as, and then I'll save it as an Electrum logo. Okay, I'm not so sure why my Electrum logo. Yeah, so it is already downloaded. So now when I come to ls, I can now see this, the Electrum logo. So we'll take it from downloads, print working directory. This is the logo that we'll be using for app image. Yeah, so terminal force, typed an application. Yeah, I think it is the only thing. Just take note of this with the testnet flag and maybe the icon one. Yeah, so I'll just save it. And go to now the executable, which is at tmp, and now just install it because it is now executable, so we'll just now install it. So it will take quite a while, and because I'll be importing my phrases, so I'll just be back. Confirm the network that we are in. So so we're in the mainnet right now. We can see by the number of blocks, 894,581. So as we saw, the testnet has over 4 million blocks. So I will just launch it, because I've not launched it from the app image, I've launched it from the terminal. So we'll continue with the setup process. So now, because we have the Electrum, the desktop, the electrum.desktop, let me just confirm. So as you can see, so this is where we have set up the testnet. So we must ensure that we run this. I'll just move it to a secure place. I'll move the electrum.desktop to somewhere else. This is user share application. Yeah. Okay, I'll need root privileges to do. So, and then I'll just make it executable. Okay, so now it is executable. Let me just confirm that it is there and it is executable. Okay, so let us just confirm that this file, there's this file in our TMP. Okay, yeah, we have the file. So now we have the app image executable, and we have the electrum.desktop. So now let us try it out. So now this is our electrum right now. So because we are launching it for the first time from the electrum.desktop, and we have set the flag, we'll do the process again, but now this time it will pick the testnet network. So we'll just kind of start again. I think I'll just set my password and then finish. So now we can see it is an Electrum testnet, and when we go to the network part, you can see the blocks, over 4 million blocks, yeah, as we saw initially. So now we have set up our Electrum wallet. So now what we just have to do, so these are currently our addresses. So this is the receiving address, and this is the change address. So now, because we want to import our descriptor wallet for us to use, I think I should be here. Because we want to import our descriptor wallet for us to use. Yeah. So what we'll do, we'll just go to Electrum. And then we can see file. We can now see the wallet information, and it will give us. So because we want to use the XPub, and Electrum provides the VPub, so what we have to do, we have to convert this VPub to an XPub. So luckily, this website that I used. There's a website that I used. I think. Okay, I think this is the website. Okay, so we can just paste and then convert it to a TPub, because it is what the testnet uses. The testnet does not use the XPub, it uses the TPub. So we'll just convert it, and converting it gives us the fingerprint and also the parent fingerprint in this case. So now this is what we'll be taking. As our TPubs. And now from it we'll be able to generate the descriptor wallet, as we'll see. So from the Electrum we can see the type. This is pay to witness pub key hash. So with this we can be able to generate everything that we'll require. Yeah, because I have some commands, so I'll just run them. So first of all, what we need is we need to know the checksum. So that we can be able to, let me just put it in one line, but close it. So what we need is to know the checksum, so that we can be able to execute it efficiently, because without the checksum we'll get an error. So I'll just do Bitcoin CLI, and then let me delete this one. So it is the same witness pub key hash. As you can see, it's a witness pub key hash. And now we'll use our very own that was generated over here. We'll use our very own that was generated. Yeah. So now this is the tpub. So what this command does, the Bitcoin CLI get description, WordPress public key hash with the. So this is the fingerprint. Currently, let me see. Electron gives us also the fingerprint. This is the fingerprint. I think it's the same 7AE, 31B, BF6. So I think it is the same fingerprint, so we won't need to change it. So now when I click enter, I'll receive the checksum. So we'll use this checksum to generate our key in the future. To as we import the descriptors, as we'll see. So now we have the checksum. So I will just append everything over here. It has given us everything. And this is what I'll do. Okay, so what did we do? So we saw, we came to Electrum. We saw the vpub, but because we are on testnet and it accepts tpub, we went to the website, converted it to a tpub, and then used the get description descriptor info to get the checksum, because for you to import it, you must have a checksum. It's a requirement. And then we took that checksum and then appended it. It gave us the whole descriptor, as you can see. Which we are using over here. So now I'll just run this command, and as you can see, so we are just using our very own descriptor 2in, the one that we got from this website. 2in, the one that we got from the website. Yeah. So there are some flags that you should know. So there's the timestamp key, which is now my own time. So it is the time that will be used. And then there's this very important key that is watch only, which is true. So watch only true just means that the private key and the public key are not in the same place. It means that we can just generate the addresses without ever knowing the private key. So it means we won't be able to spend from this wallet, but only receive from it. That is why it is a watch only wallet. So now I'm importing the descriptors. So the process that we are doing right now, I think it is creating an address. Yeah, that is the process that we are doing right now. So now we are just importing the descriptors with these ones. So this range just means that a range of addresses can be generated. So I'll just press enter. And I'm seeing requested wallet is not loaded. So our wallet is not called that. Our wallet is called, I just copy pasted, let me see. Our wallet is called watch only wallet. Control A. Our wallet is called watch only wallet. And now I can press enter, and I can see that it has been successfully imported. So we have successfully imported the descriptors. The descriptor, because for now we're just using one descriptor. So now when I list the descriptors, I can see them. I can see it. There's the timestamp, there's the active, there's the internal. Now this is now the descriptor plus the checksum. Yeah. So we have not yet generated the address, as you can see, but right now we are just telling the wallet that it should use this descriptor to generate the addresses that it will be generating. So the witness to pubkey hash uses what is called base32. Yeah, and now what we are doing, we are getting a new address, and there can be different kinds of addresses, as we'll see from this command. Let me just, okay, let me run it. Let me just confirm that I'm running it securely. Yeah. So so I'll just use the help command so that you can understand the type of addresses that we are able to generate. So these are the type of addresses. You can generate legacy, the wrapped SegWit, you can generate the native SegWit, and then you can generate the taproot. Yeah, so right now we'll be generating, because this is pay to witness pubkey hash. So this is native SegWit. It uses the base32, and it is what we'll be generating. So we'll get new address. Only in our case, we'll be using another label. So I can just say BCH for the label, and it's a base32 address. So now this is the address. So it should be starting with TB1 for our case. Let me see, TB1. I think I can just use it directly. Okay, the test network. So they begin with the TB1, as you can see from the book. So now this is the address that we can receive from any Bitcoin that we want to receive. Yeah. So the get new address just takes the label, and it takes the type, which in our case, because it is paid to witness pubkey hash, we'll use base32. And now we can now check the addresses based on our label. Our label was called BCH, and now you can see the purpose is only to receive. So you cannot spend from it, you can only receive from it. Right, so now we are done with this process. We are done with the generate or create an address. So knowing your Bitcoin address, so we have already known our Bitcoin address. It's a receive address, and this is the actual address which we can use. So we can get the address info. Just copy this. We can get the address info, as you can see. Just to be sure, so let me just to be sure we are using the our local one. So now this one gives you everything, even the script pubkey that will be used to authorize the spending. from the bitcoins that will be used. So here it is. The label is bash and everything else. So in some cases, you might maybe want a full wallet. Yeah, because this is just a receive wallet, but maybe in some cases you might have a receive wallet. So maybe we can generate that one next. But just know that we can do any descriptor, and from that descriptor we can change it. So if, for instance, it was maybe pay to pub key hash, we could have used maybe another type, not bash. If it was taproot, we could have used bash m. Yeah, so that's it. So now we'll go and generate a full address, because we'll need to spend after receiving the bitcoin, so that we can know that our Bitcoin CLI is working flawlessly. Through these processes, signing a message and verifying a message. So right now they are not supported with descriptor wallets, because we understand that the descriptor wallets, they don't store the bag of keys as the legacy wallet structure. So with them, there's just the extended private key or the extended public key. So now from the those are master private and master private public keys. So those are the ones that are used now to generate the children. So it means that there's no explicit definition. There's no explicit storage of private keys to sign or verify the transactions. So we cannot do it right now. So this command and these commands are currently not accepted, but I hope maybe in the near future maybe they'll be accepted. I don't know. So and then there's this dumping wallet. This is also not supported right now. It is not supported right now, but what you can do to maybe import, what you can do is import a descriptor inside your wallet. So you can import the same descriptor that were used in another wallet from another system. So we'll go through how to do that, and after doing that, now you can be able to view your private keys, but not the actual private keys, but the extended private keys, because it is all about master keys in this case. So that is xpriv and xpub. Yeah, so now we'll be generating the full wallet so that we can start spending from it. So now here we are. So to generate a full wallet, we'll do this. I'll just copy this and paste it. So I'll give it another. Let me just give it a full wallet label. Descriptor is true, but we are using the create wallet. The named flag just means that we are using named parameters. Just to be sure we are using the correct executable, I'll just do that. So now when we press enter, we can see it is successful. Now we have the wallets. This is the watch only wallet. I cannot see the other one. So let me just now load it. So I'll just use the load wallet. I'll just use the load wallet. Load wallet, and I will just give it the name of the wallet, which is full wallet. Full wallet. Okay, full wallet is already loaded, so maybe I just need to refresh over here. Okay, so there's the full wallet and there's the watch only wallet. So now I can get the wallet info. As you can see, so this is the wallet info. Descriptors is true. private keys enabled is true because this is not a watch only one, so it's a full one. So now let us go through the tutorial. So now instead of importing the private key, so this option was like replaced by the descriptors, list descriptors. Yeah, so it was like replaced by list descriptors. List descriptors. This one. So now instead of just dumping it to get the private keys, we understand that here we are dealing with master keys. So we can just, if we now want to include the private keys, the master private keys, what we can do, we can list. So let us first list them without the private keys. Multiple wallets are loaded, so I must provide this named because multiple wallets are loaded. So in the past we hadn't loaded multiple wallets, so that's why it was going through. So I want to list the descriptors for the full wallet, as you can see. So these are all the descriptors that are in this full wallet. So it has been generated automatically. It is not the same as the one that we imported from Electron because that was expired, a watch only wallet. So in this one you can also spend. So for easy readability, I'll just take it to the file wallet.txt so that we can maybe go through it and see. Wallet.txt. Where is it? Okay, it's in the bin, so you can just take it a step higher and a step higher. Yeah, and then maybe refresh it. So now here is the wallet.txt. So you can see now using this you can now import. So if it's watch only, you can import with the tpub. So this is like a replacement, not a replacement actually, it's like an alternative for this dump wallet. Only this time what we are dumping is only master public keys that you can use to import in a watch only wallet. But let's say for instance you want to dump also private keys. So what you can do, there are other options that you can use. What I'll just do, I'll just put the help. I'll just put the help so that we can see the other options that we have for the list descriptors. Okay, so these are the arguments that we currently have. So you can list the descriptors. So you can have the private keys. Now this is a sample command to use if you also want to list every master private key that is involved. So let us just run it. I think I'll just move the up arrow, and then instead put this as true. Okay. So now when we look at it, let me just do it over here instead. So right now you can see that uh, we are not just getting the public keys, we are getting the master private keys. So now this is just like an alternative for the dump. If you want to import it using the master private keys, now you can import it uh, from this wallet to any other wallet that you'd want to use. So when we set the true flag, it means that you want to export the private keys, right? So the other thing is that, so I've explained that the list descriptors with this set as true lists even the master private keys, lists the master private keys. If you haven't put true, it just lists uh, the master public keys. Yes. So the other thing on this tutorial with the descriptor wallets is that, okay, so I explained that you cannot sign or verify, but now we have already generated the full wallet. So now the next thing that we'll be doing, we have gotten the wallet info. Yeah, the true. So now we can get a new address from it. Let's say we want a taproot, because let me just delete this. Okay, let me just go to this wallets.txt. Okay, as you can see, there are different descriptors. So there's the pay to pub key hash, there's the script hash, there's the taproot. So let's say in case we want to generate a taproot address, a taproot was just a soft fork that came a bit recently. So if we want to generate a taproot address, because taproot uses the base32m, unlike the native SegWit that we used initially for the watch only wallet. So what we'll do, using Bitcoin CLI's full wallet, we can call it a taproot address. This is now the label, but now the type will be bash32m, because that is what taproot uses. So now when I click enter, now I get the address. You can see that it is a bit longer as compared to the other one. So I'll just replace it over here and now get the address info. Multiple addresses are loaded. So again, I need to provide this flag to indicate the exact wallet that I want to be used. Okay, yeah. Okay, method not found. Let me see. Okay, it's a flag. RPC wallet. Now you can see. So this just provides the information. So this is the address, the script pub key that determines how the Bitcoin spent here will be spent by the next recipient. Now here is the descriptor. As you can see, it is taproot. Okay, and it uses the bash32m. Okay, so here is more information. There's the witness program, the witness version. Is witness true? Is watch only is false, because it's a full wallet. We created it as a full wallet. Okay, so I think that's it. So now what we'll just do, in order to spend, of course, we must have coins, and to have coins we must go to faucets that offer test bitcoins. So I'll just try to get some. Let me see. So this one is just speaking about variables, and then we are going to receiving transactions. So I will just use this faucet over here. Bitcoin faucet, open a new tab. Okay, so it's available. I think it's opened over here. So now I will place the address that we just generated. The address that we just generated. Yeah, because we'll be using it to spend it to another wallet that is watch only. So now the wallet that we generated. So here it is. Which wallet did it generate? I think it is this one. Copy. Send test coins. So it's just verifying the process. Just verifying the process. Okay, so it might take quite a while, so I think I'll be back after the entire process was completed. So there was the unconfirmed balance command which I used to see that these ones were unconfirmed. So, but right now I can now check the balance, and I can see that our balance is this one in our wallet. So now we can continue. So now we already have this. So what we can list, we can maybe list the transactions. We can list the unspent and such. Let us just go through the tutorial. So receiving transaction. So you can get the balance. So you can get the unconfirmed balance. So this means that your transaction has not yet been confirmed, like the way we saw in our case. Unconfirmed balance was this value. Yeah, but right now it has been confirmed, and now we can see the balance that we currently have. Okay, so now we can get our wallet info. I'll just copy this command. Now we can get our wallet info. Now here we are, the balance is this one. The unconfirmed balance now is 0.0 because everything has been confirmed. Following through, discover transaction ID. So you can list transactions. You can list transactions, as you can see. You can list transactions. So currently we only have a single transaction. This is the address that received the transaction. This was the amount. The label was taproot address, 8 confirmations. So as you can see, it has just been confirmed, and we have 8 confirmations already. It means that the blocks are being generated faster in the testnet. This is the block height, the block size, the transaction ID, the SegWit witness ID, and everything else. So I didn't put the replaceable flag. So replaceable is no, because it is not from us, so we were not able to put the replaceable flag. But when sending a transaction, we can determine if it should be replaceable or not. So now we can now send a transaction. Now we can send a transaction because we have we already have our coins inside the wallet. So I'll just explicitly tell it which wallet to use. I'll just explicitly tell it which wallet to use. So I want to use the full wallet because it is the only wallet that we can spend from. The other one is watch only, we cannot spend from it. Send to address, so I will send to our watch only address. This was our watch only address. This was our watch only address. And as you can observe, this one, this address, and this address are the same. Why is that? Because they are using the same seed phrase, and they are using the same path, generation path, derivation path. So they're just the same because there's something that is called indexing. So when we generate the next one, it will be the same as this one, and yeah. So it is just because of the same seed phrase and the indexing. So now I'll just replace this with my own. And now let's say we want to send 0.001 BTCs, and then I want to subtract a fee amount. So by defining this flag, it means that Bitcoin Core will calculate for us the amount that should be for the fee, and then create a separate output for our change. So now when I press enter, you can see send to address. Now this is the transaction hash, I think. Now I can just list the transaction using the commands that we used initially. List transactions. So now we can see there are several transactions. There are several transactions. There are several transactions. So you can see the fee was calculated automatically. Yeah, so the fee that was used was this one. So the fee was automatic. Yeah, so right now I can just maybe check for, I can just list the unspent for my full wallet and see. So my unspent is empty for now. So it means I've spent everything, which is not the case. Yeah, so I'm not so sure about this send command. So I think when we get to the next chapter, we'll just send the raw transaction because it has a lot of power that we can use. So right now we can use our old wallet, not old wallet exactly, but we can now use this wallet over here and list the transactions from it. So instead of this, I can use the label for our wallet. I think was the label for our wallet was, what was the label? The label was watch only wallet. The label was watch only wallet. Yeah. Now when we look at the watch only wallet, now we can see a transaction where we received this amount of money from our other wallet, which is the full wallet. So now it also gives us the descriptor for this exact wallet. Okay, so right now you can observe that we spent it using different descriptors because our other wallet was Taproot. This wallet has the witness pub key hash. Transaction has been successful, so I think that is the most important thing about descriptor, because they carry the script that tells the wallet how to authorize transactions and how to spend and such. Yeah, so I think that's it. So so this is how you discover transaction IDs. So I think we have a transaction ID over here. Yeah, so using that transaction ID, so maybe I can just use this list unspent and see. So we are using the watch only wallet to list the unspent. So we have this unspent from this transaction ID. This is the script pub. The amount is this one. Confirmations are already 6. Solvable true. Descriptor is this one. Yeah. And then next, you can examine the exact transaction. You can examine the exact transaction by get transaction. And then listing the transaction by ID. Copy. Yeah, now this is the entire transaction. As you can see, this is the amount, the confirmations, and everything involved. Replaceable, no, we did not set the flag. Category is received. This is just a watch only one. Yeah, and then here are other information. So examine your transactions. Okay, by setting these two rules, you can choose to include what in the output. Okay, so get transaction. Okay, so we can just do this. But now we'll do it from our other wallet. Now we'll do it from our other wallet. Which command was that exactly? Get transaction. Get transaction, and then there's the transaction ID. So I think it will generate the error, but I just want to paste the transaction. Yeah, so I just want to go a step higher and list the unspent list transactions, so that I can look at an exact transaction. So now this is the exact transaction. So with these flags, so this flag shows it says include watch only to false, and then this now shows the verbose. So it includes extra information. It includes extra information that you can use, input, outputs, and whatever. So we understand that the inputs are controlled by scriptsig, and then outputs script pub key. So let me just run it and observe it from my part. You can see everything. So everything controlling this transaction, how you'll spend from it, and so I'm not right now. I have no inputs, so there's no. Oh, okay. So here is an input. Yeah. So there's the scriptsig, which is currently empty. It also shows the witness data with the sequence. We remember the structure of inputs and outputs. So if you went through the course, so you should understand what this means. And the transaction output, you should understand what this means. Yeah, so next, so you can use a block explorer. Yeah, and then this now the drawback of using a prune node. So I cannot get a raw transaction, yeah, because my transaction index is not configured to 1 because I'm using a prune node. With a prune node, you cannot use this command because this must be enabled for you to use it. So I think the next set of tutorial will be going to chapter 4, but currently this is the entire chapter 3. Yeah, so I guess I'll see you.